Where do you think the largest magma chamber in the world is located? It is not the massive 350 cubic kilometer Socorro magma body underneath the town of Socorro in New Mexico. It is also not the whopping 46,000 cubic kilometer body of magma which lies deep underneath the Yellowstone supervolcano in the state of Wyoming. Instead, the world's largest magma chamber is far larger, containing enough magma to hypothetically cover the entirety of the United States in 131 meters or 430 feet thick of lava. What I am referring to is located in a remote section of the Andes mountain range where it stretches across parts of 3 countries, Chile, Bolivia, and Argentina. Known as the Altiplano-Puna Magma Body, it contains 500,000 cubic kilometers of molten rock, which, while deep underground, is spread across an area nearly equivalent in size to the U.S. state of West Virginia. You might note that the northern of its 2 lobes has a much higher elevation than the surrounding landscape, and this is no coincidence. During the last 11 million years, it has been greatly uplifted due to repeated massive intrusions of molten rock, with a more isolated heightened episode of unrest ongoing at the Uturuntu volcano today. So, why does this magma chamber exist? Is there any danger of an eventual eruption? This video will answer these 2 questions and discuss this fascinating feature. The Altiplano-Puna Magma Body is divided into 2 sections, where the northern larger section measures 340 kilometers wide and 180 kilometers long. Underneath this, in its southern portion, is a singular supermassive body of molten rock which exists at between 10 and 20 kilometers depth. For reference, the continental crust measures 65 kilometers thick in this section of the Andes. The lower section, and thus the majority of this magma chamber, contains andesite composition magma, while its upper section is more differentiated, containing dacite composition magma. The Altiplano-Puna Magma Body has existed for 11 million years, and during this time span, its magma has not only fed unusually voluminous silicic lava flows such as this massive dacite lava flow, but also numerous highly explosive caldera-forming eruptions. This might be fairly obvious since much of this raised landscape is covered in ignimbrite, with at least 28 powerful eruptions rating on the explosivity index as a 6, 7, or 8 occurring since 11 million years ago. To understand why this magma chamber is present, we need to look further back in Earth's geologic history in a different section of the planet. Beginning around 40 million years ago in what is now the western United States, a similar series of events occurred. At the time, the Farallon tectonic plate was subducting underneath the North American plate at a very shallow angle. Due to this shallow angle, very few volcanoes were created. This process caused an extreme amount of compression, causing the uplift and formation of the Rocky Mountains. However, several million years later, something changed. The Farallon tectonic plate suddenly snapped downwards at a much steeper angle in a process called slab rollback. This caused magma to rush upwards to fill the empty space previously occupied by the tectonic plate. Large volumes of magma then creeped through the crust and erupted onto the surface through incredibly large volume explosive eruptions. This geologic event was referred to as the mid-tertiary ignimbrite flare-up, which saw the creation of dozens of supervolcanoes in a short time span in the southwestern United States. The same thing occurred in South America to produce this massive magma reservoir, with 2 key differences. The subducting tectonic plate is the Nazca plate and the colliding plate is the South American plate, and in addition a large chunk of the underlying lithosphere detached, causing mantle material to rush upwards into the crust. This is what caused the region's uplift, which is seemingly in the middle of a long-term ignimbrite flare-up that is currently undergoing a long pause in activity. Thus, the underlying magma will eventually intrude shallower into the crust, producing more massive caldera-forming eruptions in new supervolcanoes. However, we do not know when or where this will occur next, but a good guess would be the Uturuntu volcano in Bolivia hundreds to tens of thousands of years from now.